Error is how off the estimate was from reality. Okay, so let me just show you the picture real quick. All right, so if we look at, well, this was 11, right? So if we look at that point, there's the real point. That's what really happened, that gray dot, 11, 19.7. And what we estimated was right above it at the 22 value. Let me put those values in. There we go. So we estimated right here, that little line, right, or dot right there on the line, we estimated 22. But what we actually got in the real world was 19.7. Now, where's the 19.7 coming from? Well, it's all the way back here, 19.7, right there. Okay. All right. So then the question is, how off are you? That's what your error is. So there's different ways to do this for different books. Like in statistics, we always take the observed minus the predicted. So it doesn't really matter, but you can say the predicted minus the observed, or let me put this reality, or actual if you want. Here, how about this? Estimate minus actual. That would be 22.032 minus 19.7, which would be about 3.3, I think. Let me double check that. Quit. Ooh, by the way, if you're ever someplace that you don't want to be, like a graph, and you want to get out of there, second, quit. That's how you get out of there. All right, so 0.032 minus 19.7 gets you 2.332. So 2.332. I knew there were two threes in there. All right, there we go. There's our error. So we found what it actually was, 19.7. We found what it was predicted to be. We did that by hand. And we got 22.032. And then we used that in order to be able to answer the question of how off we were. All right? Now, here's the next question. Estimate when 7% of 12th graders will have used smokeless tobacco. Label it on the graph. So we labeled, oh, we never really did label the error itself. You know, I better do that. So let me copy and paste. All right, so the error itself is actually the distance in between the points. So the red dot to the gray dot, that has a distance. And that's what the error is. The error is that distance. So I'm going to say error equals 2.332. Give that the green color that the error part itself has. So it's the up and down distance between what you thought was going to happen, which is the red dot, and what actually happened, which is the kind of the grayish dot. Okay. All right, now the next one's talking about 7%. Sorry, I went back. But estimate when 7% have used smokeless tobacco. So 7% means I'm giving you the y. I'm giving you the percentage 7. Now notice these are whole numbers, so I'm not going to change 7% to a decimal. I'm going to leave it at 7. So I want 7 equals negative 1.189 times t plus 35.11. All right, now you want to get the t by itself, so you subtract 35.113 from both sides. All right, so I'll need to take 7. Oopsie. 7 take away 35.113. Enter. Oops, 113. There we go. So it's negative 28.113. Let me put that in. Equals negative 1.189t. You want to get t by itself, so you're going to have to divide by negative 1.189. And of course, if you do it to the right-hand side, you have to do it to the left-hand side as well to keep things fair and equal and all that good stuff. All right, so I'm going to take my calculator. Now you can do this two ways. You can type negative 28.113 blah blah blah, or I can just type divide. It'll take my last answer, which is this number right here, negative 28.113. I'm going to divide it by negative 1.189. 0.189. And there you go. You get that t is about 23.644. And you're done. Now, well, you're sort of done. I should be clear. You're not completely done. There's one other issue, which is namely, what year is that? We have t values, right? But when we want to estimate when this happened, knowing that t was 23.6 doesn't really do us a lot of good. We want to know what year that was. So, and this is where we get into a little bit of issue with your author, because he's not very consistent in how he likes this interpreted. Technically, this is during 2013, right? Because it's really like 64% of the way through 2013. So it's 2013 and a half, right? Or 0.6. So that's in the middle of the year 2013, right? So in the middle of 2013, which is fine. But to be honest with you, most of the time we round, and I'll put it right in here. We round this to the nearest year. So we say, okay, well, that's about 24. So I would say by 2014 for sure, right? So when you round the year to, or round to the nearest year, let's put it that way. That happens more often. Even though the 2013, it's correct. It's in the middle of that year. But to be honest with you, this is the one we use more often. Not that the other one's wrongs per se. It's just, that's just, the book is inconsistent in how it does it. So this bottom one is the one we're going to end up using more often than the other. Now I know for some of you the next one got, actually for some reason it was jumbled, so it was accidentally on the bottom of this page. So sorry about that. Get it out of there. You actually want it at the start of the next page. So it's not a really big deal. You don't have to rewrite it. Just kind of pay attention and do all the work on the next page that's blank for you at the top in case you accidentally have that jumbled a little bit. So we're supposed to find the p-intercept. Now remember, the p-intercept is where it intersects the p-axis, which would be, hold on, I gotta find this graph. There it is. Okay, so I'm gonna label it for ourselves. I'm gonna put it right over here. It's right there. So it looks like it's gonna be 35 and a little bit of change, but we're gonna be finding it exactly. Let me pick a color. How about purple? All right, so we're gonna find it and we're gonna label it p-intercept. Okay, and I'm going to make it all purple. Great. All right, so there's the p-intercept. Now we got to find it. We can tell it should be about 35, but we want to know more precisely than that. So we're going to go down here, and we're going to take our equation, and we're going to use t equals 0. So remember that when you want the p-intercept, right, that would mean that, here, hold on, means that t is equal to 0, right? That's the whole point of those intercepts, is that when you want the p-intercept, the other value is 0. Okay, so I want to let t be equal to 0 in this equation. And if you're paying attention, you might have noticed, oh, wait a second. The p-intercept has to be that back number. That's what we learned back in the day, right? That the p-intercept, the y-intercept, is what p is, right? The y-intercept is always that back number, 35.113, and this is y. So our p-intercept is 35.113. Great. We know how to do it, no problem. Ooh, but then they asked us, what does it mean? Now that's the trickier part. So finding the point is not that hard, but it's not worth that many points. You need to be able to say, in 1990, now where am I getting that from? Well, the year is 0. Never forget that your points are going t comma p, right? They set up for you in the problem which one was the x and which one was the y. It's way back here at the start. Okay, this is your x and this is your y. Okay, your t and your p. So when I write the point 0 comma 35, then I'm telling you that the t value is 0, which means I must be talking about year 0, which would be 1990, right? And it pays to somewhere write this, t comma p, year comma, hold on, let me start that. So that would be equal to year, comma, percent. Write that for yourself somewhere. When you're having to do all these story problems, it pays to know which variable is which. So in 1990, about 35.113% of 12th graders had used smokeless tobacco. Oops. There we go. Now for the next one, we need to find the t-intercept. So it's going to be the same idea, but if you want the t-intercept, that's going to mean that p is equal to 0. This is going to be trickier to find. The other one was so easy because it was already solved for p. This one, I'm going to let this be t, but I'm going to put 0 right here for p. All right, that means I'm going to have to subtract 35.111 or 113, excuse me, from both sides, right? Because you got to solve this for t. So you're going to get negative 35.113 equals negative 1.189t, and then you have to divide it by negative 1.189 to both of them because you want the t part by itself. Okay, so then these cancel. Well, cancel is a bad term. They divide, right? Negative 1.189 over negative 1.189 makes 1, right? And 1 times t is t. So you get t is equal to whatever this number is. Now notice it's positive. Let's see. Negative, make sure you use the little negative symbol down here at the bottom. 35.113 divided by negative 1.189. Enter. There you go. 29.532 if we round. Okay, so 29.532 comma 0. Now again, don't forget that's percent for the y value and t is time. So we're not talking about 1990 anymore. We're talking about 29.5, which if you round, let me just do that a little bit quickly. If you round, that's about 30, 0 if you round to the nearest year because the 0.5 rounds up. Okay, so in about 2020, right? 2020, 2019, 30 years, so 2020, no 12th graders will have tried smokeless tobacco, according to our model. Now, is that probably perfectly accurate? Well, probably not. I mean, somebody will have tried it somewhere, but it's definitely decreasing. And so the model predicts, I mean, that's another way you can write it. You could say the model predicts that no 12th graders will have used smokeless tobacco by 2020. Something like that. Now this good thing to notice is that the way you interpret this stuff, the way you write up the interpretation part is not going to be exactly the same all the time. What's important is that you do two things. One, you make a complete sentence that makes sense mathematically and so on. And two, you have to explain both numbers. Intercepts have 2 points, or excuse me, 2 coordinates. They have the x and they have the y, in this case the t and the p, and you have to explain both of them. And you have to explain it in a way that makes sense. And you always want to kind of throw in this approximate, exactly, into 2020 according to the model, something like that. Just to say it's not really going to be this way, but it should be close, at least as far as the model is concerned. Last but not least, for what values of t does model breakdown occur? Model breakdown means your model makes no sense whatsoever. And that would be any year after 2020, because if you're 0 at 2020, then anything after that would be negative, which is impossible. And that's because this is a decreasing line. That's what would make it negative. See here, look at the picture. Here's 2020, after that, negative. No good to you.